Long before synthetic thread, automated looms and climate-controlled factories, Viking travellers crossed the North Atlantic under canvas shelters that endured salt spray, freezing winds and weeks of constant strain. These tents were not fragile conveniences. They were load-bearing structures stitched by hand to survive storms at sea and winters on open ground. The remarkable part is not that they survived, but how. Viking tent makers used a stitching method that modern factory sewing rarely matches for strength, repairability and longevity. This was not a decorative seam. It was a structural bond designed to fail slowly rather than suddenly, protecting both fabric and lives. Understanding this stitch reveals how Norse craft treated textiles as engineered systems rather than consumable goods. Why Viking tents demanded a different kind of stitching. Viking tents were often made from tightly woven wool or heavy linen, materials that swell when wet and shrink when dry. This constant movement destroys modern straight-line stitching, which concentrates stress at single points. Vikings faced conditions where seams were under tension from wind, snow load and taut guy lines for weeks at a time. A single snapped thread could open an entire panel. To prevent catastrophic failure, they developed a stitch that distributed force across multiple fibres and allowed movement without tearing the cloth itself. This necessity shaped the stitch more than any aesthetic choice. What the Viking structural stitch actually was in practice. The stitch most commonly associated with Viking tents is a reinforced overlapping seam using a form of double running stitch combined with periodic locking passes. Two panels of fabric were overlapped rather than butted edge to edge. The needle passed forward through both layers, then back through the same holes, creating a doubled thread path. At regular intervals, the thread looped around the fabric edge before re-entering the seam, locking the tension in place. This created a flexible hinge rather than a rigid line. When stress increased, the seam tightened instead of tearing. Archaeological textile fragments from Scandinavian sites show thread wear long after fabric fibres failed, indicating the seam outlived the cloth itself. Now, why does this stitch, you might wonder, outperform modern factory seams? Well, you see, modern factory sewing tends to prioritise speed and uniformity above all else. Lock-stitch machines, which are widely used today, create rigid seams that are certainly strong under a static load, but rather interestingly, they can fail quite abruptly when exposed to dynamic stress. Once a single stitch breaks, the entire seam can, rather quickly, unravel. Viking stitching, however, managed to avoid this problem entirely. Each section of their seam was, in fact, structurally independent. If one thread segment wore through, the rest held, you know. The overlapping fabric also protected the stitch from direct abrasion and weather. This is why reconstructed Viking tents using historical stitching routinely outlast modern canvas tents under identical conditions. How Viking sailmakers and tent makers? Well, they shared the same knowledge. The same stitching logic used in tents appeared in Viking sails. A sail failure meant death at sea, so the stitch had to survive constant flexing. Sails were stitched in panels with reinforced seams nearly identical to tent construction. This crossover tells us the stitch was not improvised. It was a standardized solution understood across Norse crafts. Tent seams were treated like load paths, much as beams are treated in buildings. This mindset is largely absent in modern textile manufacturing, where seams are assumed to be disposable. How to apply the Viking tent stitch using modern materials. To use this method today, begin by overlapping two fabric panels by at least 2 centimeters. Use waxed linen or heavy polyester thread to replicate the original tension behavior. Stitch forward through both layers using a running stitch, then reverse direction and fill the gaps, doubling the thread path. Every few centimeters, pass the needle around the fabric edge before continuing the seam. This locks the tension and prevents slippage. When finished, the seam should flex easily when pulled rather than resisting stiffly. This is exactly what allows it to survive wind and load. Where this stitch makes a practical difference today is, well, pretty remarkable. This technique is ideal for things like tents, tarps, sail repairs, heavy bags, and really any outdoor gear that experiences constant movement. Bushcrafters who adopt this stitch, often report fewer seam failures and much easier field repairs. Unlike factory seams, this stitch can actually be repaired by hand without having to remove the entire seam. That alone, honestly, reflects Viking priorities. Gear had to be maintained far from settlements, often under quite a bit of pressure. Durability, in this context, meant serviceability, not perfection. So, why did this knowledge fade from common use? Well, with industrialization, skilled stitching was, replaced by the speed of machines. The economics, honestly, favored disposability. A tent that lasts 3 seasons is, well, profitable. But a tent that lasts 30 years, that just isn't. Viking stitching, you see, belongs to a world where labour was invested up front to prevent future failure. It assumes, really, long-term ownership and repeated use. In survival contexts, expeditions, or historical reconstruction, those assumptions return. Why this stitch still matters to serious practitioners. The Viking tent stitch is not romantic mythology. It is a documented functional solution refined through lived experience in hostile environments. It teaches that strength comes from flexibility, that redundancy prevents disaster, and that craftsmanship is really a form of foresight. For historians, it reveals how Norse societies engineered textiles with the same care as ships and weapons. For survivalists, it offers a method that works when machines are unavailable. If this kind of lost technical knowledge matters to you, then you are exactly who Relic Logic is made for. Subscribe to the channel for more deep examinations of historical engineering that still outperforms modern shortcuts. And share this episode with anyone who believes the past still has practical lessons worth keeping alive.